Hey, didn't notice that I was muted. Sorry. Hey, hello. So we are back here, and let's get started. Welcome to this week. It's like Python abstract based classes, so it's Python ABC here. And yes, no sound. Sorry about that. I noticed now. Thank you for reminding me. Like I love when people kind of tell me about things that that went wrong because it always happened to me. I'm so dumb with like all this technical setup. But anyway, it's snowing in London, and I'm not going out. I don't like stepping on snows because it's super slippery. But I hope to go out to buy some veg today, so we'll see after this streaming and see how things goes. So yeah, it's about like Python abstract based classes. So it's Python ABC here. I just found it funny to say it that way, and but also, last week I encountered it, and hey, hello, hello, yeah. The day is okay. I mean, like I'm staying indoor as long as there's snow on the floor. Cause yeah, you never know. Like, cause I've been walking on snow before in London. The street is so dirty, and like I basically walk like a penguin, and I hope that didn't slip and fall because I just don't want to like put my butt on the dark black slushy on the floor. So yeah, it's not fun snowing in London, even though it's beautiful to just look outside. But yeah, I will see how it goes. Okay. So Python abstract based classes, I came across it last week for when I was talking about what was I talking about last week? I was talking about what's inside Python. Yeah, so I came across the abstract based classes a little bit. So it's very interesting because I think it kind of first goes to the very basic of what is the objects in Python. So last week we explored a little bit. We look at what's inside Python object. We look at all the internals in it, and we see that actually for every object there is a class. So maybe we do a little bit of recap of what we see last week. So here, so I'm here in this. So let me go into Python like usual. So what I do, for example, if I import, um, okay, what do I have in this environment? I forgot which environment I'm in. So maybe I would wait. Okay, let me one step backward to see what the pip list what I have, what I can import. Okay, I got loads of things, which is good. So I think last week I was playing with the Terminus DB client. I think I would do the same. So Python, and okay, just push this up a little bit. Import Terminus DB client underscore client. Oh, there's no auto. Okay, that's fine. Us TDB. That's fine. And after I import it, I can do a dir tdb, right? Because it has been imported, so it's a Python object, and I can look at what's inside. So for example, I have a class inside this package. So what I can do is that I could do a dir tdb, and then I can do this like Waco class and see what's inside. So inside you can see that there is a default like default attribute, or like whatever you call it, a default thing here called class. So we can actually print that out. So tdb dot waco class dot class here, and then you see that, oh, this is a class type. So now we know that actually this class object has the class type. So if we look at the dir of this thing, right? So this is a type object. So if we look at dir of this, and then we see that it actually is a is a abstract methods. There's some abstract methods. There's some like bases. So there's all these things here that make this thing interesting. So um, we could look at some of these things. So we could dive deep down into it. But we can also, of course, look at the documentation. But for example, we can see the basis of it to see what we have. And yeah, I love doing this thing. I can do this all day, like I said, because yeah, this is just a rabbit hole of exploration. Oops, I forgot to put the underscore here. So you see that this is another thing. So there's like basis of this class object, and it is also class of this. So what is this one? So yeah, things are getting really crazy here. So you see that here. So okay, it kind of like it doesn't make sense right now, but I think like when we look at the documentation and everything later, then this will become back into it. So okay, so this is tuple. So everything actually have a type. So every object in Python actually have a type. So we have tuple, we have the class type itself. So there are all these crazy things. So what are these things? So what is the class of tuple? So if I create a tuple, so for example, my tuple equals to a tuple, one, two, things like that. And then I can actually, again, look at the maybe my tuple class to see what it is, right? Yep, wrong. Yep, yeah, it's a class tuple. Um, so it just kind of tell you what kind of object it is. So, but you know, yeah, we have objects that like that. For example, we can also create, an integer, and it could be, as you can guess, that my int dot class would be an integer. But the thing is that if so what is the class of an integer, which is a type? So I think I have done something like that import types. Can I do that? No, I forgot how to do that import. Typing. Yeah, so there are actually like in typing there are actually different types, right? So let's see. Yeah, so we got all these. So we got any of these things, but we got dictionary, we got list, we got a tuple as well. So we can see what this is. So if I do like a typing dot tuple, so it should be, sorry, typing dot tuple dot class. So we can see what it is. It's a typing. So typing actually define a class of this thing. So yeah, what are these things? Like why there's like sometimes we can define a class of something, and sometimes it's like um some standard thing. So we are going to explore this today. So yeah, so it has been like very like I think complicated, but we would look at it, so we have looked at it kind of like just exploring, kind of like top down level, but now we are like looking at like bottom up to see what it is. So yeah, so like it says that, okay, let me zoom in a little bit bigger. So it says that there's like these like abstract big classes in Python. So yeah, it's kind of like wow, there's like 3,119. Um, so yeah, that's like something that's in Python. So okay, so there's collection module. So okay, if we can import ABC here. So how to use this thing? So let's look at it. That it says that it is it's kind of a basic thing that you could, for example, you can declare my own like your own thing, and then you kind of extend it for some reason. So but what is this, right? So this module provides metaclass ABC meta for defining abstract base classes. So let's look at abstract base classes here. So it explains that it's a duck typing phase when, yeah. So sometimes we if I, for example, if I make my own kind of class object, so how to check, like, sometimes like, I would do things like, okay, check whether this is, for example, I create query objects of Terminus DB, so whether it's like my query object in Terminus DB that I have to check whether it has, for example, the attribute of to JSON or to dictionary, because that's something that I know that any object of my query object, Wacom query object has that attribute, that I could do that, um, but actually it's not very elegant to do that, because you can also create another object, another class that also has two dictionary and two JSON, but it's totally different thing. It's nothing to do with my Wacom query object. So it's a shortcut way of doing that, but it's clumsy, and sometimes it could lead to some unexpected result. So ABC, abstract based classes, provide a way of doing it. So yeah, so it's like classes that don't inherit from a class but still recognized by its instance is subclass. So so we can see an example of the built-in ABCs, then maybe we'll get a better understanding of it. So collections, yeah, number modules, yeah. Okay, so maybe we could have a look at these collections.abc modules to see what we have. And yeah, so for these are actually our abstract-based classes, the iterables, and are actually abstract-based classes. So you may come into sometimes you have an error message in Python that is saying that something is not iterable. So that's why there's an error. So iterable actually is a kind of type of Python object that if it's iterable, then you can carry out certain um, operations. So so it has its own method that is iter. So well, so if you don't have an iter, then you can't really like you know call it, right? You can't really like do things like when you have a for loop, you have like the next, which is like is actually the method of an iterator, but it's also inherits from iterable. Uh, so it's kind of like a subset of iterable. So in an iterable, it will have an iter, and in an iterator, it needs to have an iter and a next. So for iterable, it doesn't need to have a next, but because if you call iter, it will generate an iterator that have a next, then you can loop through it. So yeah, it's kind of like that. Also, there are other things. For example, a collection object. So it needs to have a size. It needs to be iterable, and it needs to be, like a container, kind of like a subset of a container. Um, yeah, so you see that like all these abstract-based classes is corresponding to an abstract method. So instead of just checking that whether this object has a length, we can just check that if it's like a sized object. So for example, yeah, there are all these some of these things that you have encountered before. So like a mapping object is actually an object that has these things, and also it has the things that is in collection, right? So basically, it's just a name to describe an object that is having certain method that is available. So yeah, all these are async. So awaitable. So like if you have tried writing async, you will see this, right? So it's like, can you call await? So this is the way of like checking it. Coroutine, you have to be able to send it and float it. Yeah, so it's all these things that this is all the standards that the built-in ones that Python provide. But of course, the reason of having ABC that you can import ABC is that you can create your own. So you can customize one that basically follow your own logic of checking whether something can do something. Um, so yeah, so this is the idea. So let's go back to where we were. Um, yeah, so this is how you do it, right? So this is just saying that yeah, you can extend it from ABC, so you can have your own abstract class by just extending this, because this is kind of like a mother of all these abstract classes. So remember that in that table that we had here, that something is always extending from somewhere, right? So for example, yeah, iterator is like inherit from iterable. So like it needs to inherit from something. So it provides something like the mother of it that you can inherit from it. So so you can create your own abstract-based class by inherit from this abstract-based the grandmother of abstract-based class that you can inherit it from. So yeah, or you can do something like that. That's like the meta class. So what's the difference between these two? This is the question that I have in mind. So um, okay, so a meta class is the meta class of an a. Okay, so you have the abstract based class, but you also have the meta class of the abstract based class. So it kind of come in as a pair. Um, yeah, so you can use this meta class to create a abstract based class. Um, yeah, you can either subclass an ABC, or you can so it will be a mixing class. So it's kind of like those that you see that something is inherit from something, but you can also create an abstract base class directly from using the ABC meta. Um, so here that is some other things that is saying what you can do. Okay, for example, here I have my iterable that it has the abstract method. So remember that table. So for each meta class, we have a abstract method. So you have to declare that, okay, this is my iterable type. You need to have, of course, like an iterable. You need to have an iter. So this is the abstract method that that it is basically it's like it need to be there to be like to be my iterable. But also it got other things like it would have get iterator. It could have like a class method as well that you define it yourself. Um, so yeah, it used the subclass hook. So yeah, this is getting more complicated here. So maybe we could avoid that. Yeah, we can look at the abstract method here. Yeah, using this decorator, then we can class meta class is yeah. So it needs to be used with abstract base class. So you can't just like have a class and randomly put this in. um, so yeah, normal supercore mechanism. So yeah, you have to use this, and you make this an a abstract method, and yeah. So you can have other things as well. You can make this a property that is like a meta class property. No, a meta class property will abstract class property. So I need to have that one. So yeah, so it's kind of generating some so abstract class is basically generating some umbrella terms for all different type of classes. For example, I have two classes that is like one class is like, let's say, cat, and the other class is dog, and then I can have abstract classes called pets, right? So and then like because cats and dog both maybe let's say have a method that is called um, pet. You can patch them. So this patch method you can make it an abstract class method, abstract method. So then you can have like this um, pet abstract class would recognize cats and dogs are both under its it's also a pet. Um, yeah, it's kind of like that. So yeah, let's explore that and then see if we can try it out and do something about it, or we can look at some other tutorials and like have a better understanding of it. So um, an ABC can be yeah. So we were here, right? And then subclass hook. Yeah, you can use subclass hook, but this is like more advanced thing, I think. Yeah, defined as a class method. This is like when you define a meta class, then you have these like subclass hook that like define how things are subclasses from it, I think. So yeah. Um, any iter in B or dictionary for B in C. Wow. Okay, this is like really complicated thing. Not implemented. So yeah, I think it's just checking like yeah whether it's a iterable or something. Hmm. Key class method. Let's check this out. Okay, it's just the same thing. The subclass is considered a subclass of this ABC. Yeah, so it. Hmm. Okay, so it defined that a subclass. How does it check whether something is a subclass of it? So in that example, that's super complicated. It just checked that whether it's contained that method. Um, yeah, so it returned true, false, or not implemented. This is interesting. Like this is kind of something that you can also return, not just true and false. Um, not implemented. Continue with usual mechanism. Okay, so it's whether it's true or not, or not implemented. So it's just like basically skip all the checks, I think. Um, right. So, okay, so this is kind of like the official documentation. We have a basic idea. It's still a little bit tricky to understand, I think. So let's have a look to see if we have better resources out there. I think there's some tutorials here and there. Yeah, so let's see if we can look at a tutorial. Okay, so this is a Python course that's available online. So if it's good, then I would definitely put the link somewhere. So of course, give some shout out to some good resources, and also you can check that out yourself. Um, so okay, this is a tutorial. Just making an example here that like any class you have an init, and then you also have an abstract method that, like we said, that because it's an ABC, so we will create a abstract method by using this decorator. So yeah, so this is easier than messing with the meta class, I think. Um, so so we can create another class, and then this class actually is something that is inherit from this abstract class example. Um, but can I initiate a class? Yeah, because it doesn't have the method do something, it just basically create an error. So it's like if, for example, what I can do as an example. So for example, if I create a let's say if I do a class, my what would that be? My iterator. So I inherit from iterator. Oh, I think I have to import iterator first. Can I do that? Maybe not. Okay, so yeah. Okay, so I'll go back to this later. Right, I have to import that from collection first. So okay, maybe do that import iterator from collection. I think no, from iterator. Oh, sorry. What am I doing? What am I thinking? Import iterator. Okay, this is collections maybe. Yeah. Oh, warning. Oh, so it's in collections.abc. Okay, I think it will still work. So, okay, class my iter is actually iterator. Okay, so if I do a da init, oops, under init, then basically, yeah, I do the same thing. I do a past, and then if I create an iter, so my iter equals to my iter, and yeah, I will have a warning because I don't have next, because I have inherited my iter from iterator, so it's any object that I create, any my iter object that I create supposed to be an iterator because it's inherit from iterator, right? So it needs to be an iterator. But because I don't have next, so basically this thing, this funny thing that my iter created is not an iterator, so it violates the rules. So it says that no, like you can't create an instance because you break the rules. You're in jail now. You can't do that. So you need to have an abstract method next. So for example, if I create another one that my iter2, another class now. This time I hope I will do better. Okay, iterator. This is not doing better. I can't even spell it. Okay, so this time I dove and maybe iter. What am I doing? My brain is really funny. Okay, self. I don't care. So this one I would maybe. Yeah, I just do a pass. This would not work in any sense, but I just want to make sure that it kind of follows the Python rules, so at least I can create an object, even though it will create an object that doesn't work. So again, I would just like put itself here for whatever reason, and then again, just do nothing. But I have a past method now. So let's see if this one works. So if I do a my iter2, so yeah, now I can create my iter. So my iter is an object. So if I do dir my iter, then now I can have all these things. Of course, I will have a next, which is here, because it's the iterator. So I can actually check is iterator, no, is class, is it like, is instance, yeah, or something like that. Oh no, not instance. Yeah, it's subclass or something. Yeah, so like, okay, so I can check class here. So yeah, I forgot like what's the function of checking the whether it's an iterator, but yeah. So you see that it's actually a class that I created is the my iter2. So this is the object that I created, and it's fine. It doesn't go to jail because I follow the rules. It got next because it's an iterator. So actually, I can yeah, maybe I can check whether it's an instance. Okay, it's instance of a I put like my iter. So is iterator, I think like that. Yeah, so it's true. So it's an iterator, right? Um, so everything is fine. So because yeah, because I didn't break the rules. So abstract class lets you create these rules to check it. So make sure that no one really breaks the rules that you created. Um, yeah, so this is like what this is doing, and then yeah, so this is like doing it correctly. You have to do something. So okay, Python is happy because you do have to do something. Um, and here, what is it doing? So, mm, so one thing. So here in my example, I use the iterator, right? So iterator is something that's created by the Python built-in. So so using abstract class object here, for example, in this tutorial, they use the abstract class example here. So this thing is basically let you create your own. So instead of using those like iterator, like the tuple or like the collections and all these things that Python provided, you can create your own. So this is how like abstract base class is useful for. And like I said, you can create your own rules, so make sure that no one is breaking those rules. Um, yeah, so shall I go into the meta class so kind of like we can look at it maybe? So okay, so this is how you can do things with abstract based classes. It's actually quite straightforward once you understand it. It's just like those things that you encounter, like the iter, like the generator, like the awaitables. So so instead of those that they have their own rules, you can create one, your own abstract class object that have your own rules, right? So everything needs to be following that rule. Um, so now we are going into the meta class, which is something that again like is something complicated but very interesting. I think we do have time to cover it today. If we don't have time to cover everything about meta class, we'll continue next week. But I think we can get a little understanding of it this week. Um, yeah, this is also new for me. Disclaimer, like I just came across it in my Python journey. I think that I would do it together with you all and share my experience. So yeah, I think I would also maybe share the link of this. Yeah, I'll share the link of this tutorial here. Is okay, so it's python-course.eu. So if you want to check that out, please do. They also have a German version, which is quite nice. So yeah, this shout out to them. I also have a look at who created it, and also like yeah, you can donate as well if you have been enjoying this tutorial. Again, please support them. It's really good. So let's move forward and check out the meta class. So um, hmm, yeah. Okay, so we haven't looked at the introduction to meta class. Let's look at it for now. So yeah, we have actually came across metaclass briefly, but we don't actually understand like what it is. So let's have a deeper look. So metaclass is a class that the instance are classes. So in this case, I create my iter. So iter is the iterable. Yeah, it's an iterator because my iter I created from these my iter2, which is inherit from iterator. So any instance that I created is an iterator. What if I want to create a class, that any instance that I created is a class? Boom. Mind blown. Okay, so let me say that again, and see if you can absorb that. So in this my iter thing, okay, so I have a class my iter2 because it's inherits from an iterator, right? So any objects that I created, for example, my iter here, that it's an iterator, so it would be an iterator is true, right? What if I want to create a class instead of, or the instance that I create from this class is an iterator, or the instance I create from this class is a class? Then that class that I used to create this class is called metaclass. Okay, so this is what a metaclass is. Um, so how should we do that? So let's have a look. Um, so it's very funny because the behavior could be a little bit different, as you can imagine. Um, yeah, so it's yeah, metaclass is something very unique for Python, I think, because it's for a lot of object-oriented programming language, it's not something that is supported. So it's very useful. I think it's like, well, at least it's powerful. Well, useful or not, I think we'll look at the use case later. But yeah, it's something that's very powerful. Like lets you customize and like have full control of things. So so metaclass is actually defined just like another Python class, but they inherit from type. So this grandfather of metaclass is type. So it's just like what we looked at before, right? Remember, iterator was the father of iterator, the mother, father or mother. Yeah, because I don't know the gender of an iterator or iterable, so I don't know. But like the parent of an iterator is iterable, right? Remember? So iterator is inherit from iterable. And then my iter is inherit from iterator. So the grandparent of my iter2 actually is iterable. So anything is inherit from anything, right? So like we look at the table before, I think collectible or something contains or something. I forgot the name, but yeah, like you have to have something to inherit your thing from. So the great 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 grandparent of any meta class is type. So anything inherit from type would be a meta class. So that's so when you look at a Python code, right? So you just say that like if you see anything here like this that is inherit from a type, then you know that this is a meta class. You can just point at it and say meta class. So yeah, this is how you just like kind of spot a meta class. Of course, you can have a grandchild of type that, like, for example, one child of type is int, so integer is a child of type. So anything you inherit from int, for example, maybe you inherit that is only even number, so that one would be a grandchild of type is also a meta class. Yeah, so no meta class keyword is pass. So okay, so there are some rules here. Um, Another difference is a meta class is called automatically when a class statement is using a meta class ends. Okay, so no meta class keyword is passed after the base classes. Okay, it's difficult to understand this sentence. After the base classes, yeah, there may be no base class. I've never seen anything like this. So everything is just class, right? So it's nothing called like, well, oh, okay. I think it means that like you have to define this first before you can use meta class equals to something, I think. Um, but yeah, but we'll understand more when we go along. Um, will be called if meta class keyword is used. On the other hand, the class assigned it will be called instead of type. Okay, so I think it means that anything that you created like this, that actually the meta class would be defined as type. So the meta class of this class S would be type. So that's the default, right? But if you do something like that say like, oh, meta class is little matter, then it will be little matter. So even though it inherit from S, so I think that's what it means. Correct me if I'm wrong. If someone's watching and you know better, let me know. Yeah, this is a bit difficult to understand. Okay, so maybe look at the example. That may be more, maybe better. Create a very simple meta class. Okay, it's an example, a new method. Okay, so for a meta class, we have a new method. So instead of having init, we have new. So new here, so instead of passing self, it will pass CRS, which is the class it created, because it created class, right? It doesn't create an instance. So instead of self, it will be CRS. So instead of init, it will be new. So yeah, in a new method, return the type new. So it will return the type.new instead. So actually inside type there is a new method in it as well, of course. Like I think it's kind of the subclass abstract method of type, right? So you have to have new to be a meta class. Um, so you can call the type new. So you can just call this one from type, and then you will pass in similar things. You will pass in the class name. Just pass it down. Of course, class. You can pass in the same superclass, pass in the same. So you just basically boost bootstrapping, I would say, from the type new. But here the trick that we do is just that we will just print it out when a new class is declared, right? A new class is created. So here we are putting that to use here. So a equals to a, and then we'll have all these things like if we create an instance, right? So here this one is a normal class. So we just create a new instance with class, and well, it doesn't have any needs. That's funny, but we'll see that later. But here, because the meta class is the little matter, so it will print out everything, right? So the class name is A for this A here, and then the superclasses, because it's inherit from S, right? So the superclass is S, and then all these other things. Okay, so yeah, because we use this meta class here, so I think what I was saying before is correct. So because I use the meta class here, so it will call this new instead of the type.new. So that's why everything will be printed. Yeah. So, right. So now there's all these crazy things. So this like we have a class that is inherit from type. There's also an init. So um, I think they will explain the difference of new and init, right? So um, I don't want to explain it now because I may do it wrong. New is actually like create. So instead of so init is that when so new is that when an instance is created. No, init is like it would trigger when an instance is created. New is created when you call this class thing, I think. So it's called so it's like when a new so I think it's just like one is like when it was born. I think new is like when the instance was born, and init was like after it was born, then we call it init. I think that's the difference. I may be wrong. Again, correct me if I'm wrong, but let's go forward and we will see. Um, so yeah, you have to really take my word like really carefully now because like I said, this is also new to me. I have someone that like I've encountered it before, but not too much. So I may say something wrong. Correct me if you know. Um, yeah. So here we have an input, and then we just like answer, right? Um, Then we have the answer. So we have this. Okay, this is an meta class because it's inherit from type, and it has an init instead this time. And then you also take in a class again, like I said, because this is a it created a class. So you have a class name, class, all these things. And if required, which is this thing, here is kind of a global variable, then the answer equals to the answer, and philosopher, the three philosopher, they're all you know the classes of this meta class. So this will be triggered when we created these philosophers. Um, okay, so um, Plato is the philosopher one, and you can call Plato dot on the answer because we have the answer here. So Yeah, I think that's what it's calling. Let's see what happened to say, okay, do you need the answer? Yes. And then it will print out the answer. Why is okay? So the answer is set to the 42 here. So we can okay. So this is setting the class method, the answer to be this return 42. So um, so if we are asking for the input, if the input is y, then requires is true. So we would have the answer attached to the class that I created. If not, then well, it should not have that. So so if you answer yes, then yeah, both of these would have the answer, right? So but what's the difference? Okay, so we have learned in. So what are you trying to show? Type and class relationship after the class definition. So have you hooked to the meta class? Yeah. So to be precise, argument recall set to these values. Yeah, so I still don't get why they have to illustrate it this way. It's very delusional, I think. Um, automatically include our argument answer method. Okay, so it's kind of like a way of putting a method in it, but okay, maybe I don't see the point of doing it, but okay. Oh, you can create a singleton. Haha, this is getting more and more useful, I would say, more practical. Um, Singleton is a pattern that, well, singleton, it just means that you can't, so the object is unique. So exactly one object is needed. You can't create two objects that, work in parallel, so you can only have one object of that. So that's the singleton. Um, so restricted, yeah, the installation of a certain or fixed number of objects. Yeah, singleton is a unit set. Yeah. So anything that you refer to it is still the same thing because it's a singleton. Only one of that kind exists. Okay, so you have a metaclass singleton. So it's a metaclass, and instance is blank for now. Okay, so if you call this singleton class, if you create that, then um, okay, so any class that, if it's new, if it doesn't exist yet, then you can, of course, create a singleton, I think. So if not in that, then it's instance. Then you put the class in there, that it will point to the super singleton.call. So it would just call this one back. So it would just create it and return the instance. So this is just checking that if it's already exists, don't create another one because it's a singleton. You can't have the second one. It should point back to the first one if it's the same thing. Otherwise, it would just create that one. Well, it will store it inside and then create that one. Um, so a singleton class, well, is you have to use the meta class, of course. A regular class is just a regular class, and then okay, so if you create a X is a singleton class, Y is a singleton class, then it should be the same, right? Yeah. Otherwise, it could be two things, two different instances that created under the same class. But a singleton class is always the same thing because it will check if it's already there, then just give the same thing back. If not, then you can create a new one. So this is, I think, it's more a very typical example how you can do that. Maybe some interview question will ask you like how to create a singleton meta class. So yeah, well, it's good to know. I think if you're wanting to get a Python developer job, then maybe this is something that you have to learn. Yeah. So I can see this as an interview question. How do you create a singleton class, right? Yeah, this is how you can do it. We can create a singleton class. We inherit from a singleton class. Yeah, so it's an object this time. So this is not a meta class, but you can create this class and then you can inherit this from here. Yeah, so it's the same things, but instead of using meta class, you just inherit singleton as an object. Um, yeah, it's basically the same thing. It's just a different way of doing it. So How much time do I have? I have 10 minutes. Do I want to go further? So this is yeah, this is how we what is a meta class, and then I think there's the last piece of the puzzle is how to use abstract based class with meta class, which is the meta ABC meta. So let's see if we can go back to that count call. Oh, why is it different? Where were I? Okay, yeah, go back to ABC, and so there's the next thing is to okay, meta class use case counts function calls. Okay, so this is adventuring further of like how to use meta class, and you can count how many times it's called. I think it's useful if you have like a kind of a service that yeah, then you may care about how like the function calls. Um, yeah, I think I won't go through this one. I don't think I have enough time to go through everything here, so maybe I would see if I can do a quick recap. So yeah, so abstract based class basically is a class that uh, would check whether you would have a certain abstract method. So it's kind of like an umbrella term of different classes that all these classes have has a common uh, character that they would also have the abstract method. For example, Iterator is an abstract class, and then all the things under Iterator for all these class to be classified as an iterator, that they all need to have the abstract method next. Okay, this done the next. Um, so uh, so it kind of makes it very neat because if you define, for example, if you define something as an iterator, then you can check whether anything that fulfill this criteria is instance. That instead of checking whether it has a next, you can just use its instance, checking whether this thing is an iterator. So Iterator is one of the built-in abstract class that Python provided, and with ABC, which is a standard library, so you can import ABC, then you could create your own. It could be something that's not an iterator. You can create your own abstract method. You can create the same abstract, like the abstract class containing that abstract method, and kind of create your own rules for people to create classes that is classify as that abstract class. So that's abstract class. Another thing that we touch on is the meta class. So meta class is so instead of creating an instance from a class, meta class create a class. So it's so any meta class is inherit from type. Type is a grandfather of meta class. So what is the meta class of type? Is type. So type is the grandfather. You can't go further up the hierarchy from type because it just go back to itself. Um, a meta class. So there's a few difference from meta class. Instead of like init, you will have a self. It will have a CRS because it instead of creating an instance, it creates a class. With meta class, like for if you want to declare a class that the meta class, for example, if you create a meta class called myMeta, if you want to have a class that the meta class is myMeta instead of type, then you have to use, in here, then you have to type. Uh, so here, after iterator, then you have to type meta class equals to myMeta. Um, so anything that we talk about meta class, I think we basically cover more or less. So if it's a meta, if it's a like if you declare the meta class here, that instead of like when you create a class, instead of calling the new from type, then you just it would call the new from the meta class that the custom meta class that you created if you have a new in there. Otherwise, it would just call the same one from type because it's inherit from there, right? Um, it's useful if you want to create a singleton class. So make sure you check that out. Check that page out. It's in Python course.eu. So make sure you check that out. It's like how to create a singleton class from that because I think that would be very a very popular interview question if you want to apply for a Python developer job. So yeah, make sure you check out this tutorial. There's like Python course, python-course.eu. And also make sure if you benefit from it, if you get a job because you have read through the tutorial, make sure you donate and support them, support their good work. Yeah, I love the Python community. There are lots of very devoting people providing material, providing all these like resources for us to use. Really appreciate them. And I think that's it for me for this week. And yeah, and then looking forward to what's going on next week. I still have no idea yet, but yeah, I'll let you know on Twitter. So that's it for this week. So I will see you soon. Bye.